Hi everybody. Welcome to everyone in the room and welcome to the people online. This is one of ODI's Friday lunchtime lectures. The topic for today is something that I, in particular, have become a little bit mildly obsessed with, which is linked data. So at ODI, we kind of recognise that a lot of the value and innovation that comes from using data comes from the kind of almost infinite ways, it feels like sometimes, of combining data and gaining insight from that. But as someone who, so I'm a researcher here, and I have had some painful experiences with that in the past. I think the worst one was trying to combine data sets that had different output areas from different years, if anyone's ever worked with ONS output area codes. Any sort of ways of thinking about how to solve that problem and systems for resolving that problem are obviously incredibly valuable. So to speak about that today, we've got Benjamin here, Benjamin Rowe. He's a PhD student at LS2N Digital Sciences Lab, which is based in Nantes, but also is working with OpenDataSoft. Benjamin's field of research is the semantic web, and he's putting that background into an actual product that is designed to help non-specialists, so those of us who don't have that deep technical understanding of how to map out and connect data sets in this way. That's what these guys are trying to solve. With Benjamin, we have Pietro and Fanny over here. So they are based in OpenDataSoft's London office. So anyone who'd like to have conversations, please feel free to ask them afterwards as well. So okay, without further ado, I'll hand over to you, Benjamin.
Thank you. Thank you for the introduction, and thank you all to be here at this session. So the purpose of this presentation is to explain what is linked data and how and why OpenDataSoft is interested in linked data. Okay. So first, what is linked data? So to understand what is linked data, we need to understand structured data first. Okay. So there are a lot of structured data on the web, like for example, Excel spreadsheets or relational databases, okay, are structured data. Here we have an example of structured data organized in columns, okay? And some structured data use also data types. So for example, you can know if a column will contain integer or will contain strings, dates, etc. And this organization in column have a good advantage. It is that it's machine readable. Okay? So there is one disadvantage with this kind of data. It is that without having metadatas, it can be a little tough to understand the meaning of the data. So for example, here we have a problem understanding the relation between columns. So here we have the number of review column, but we don't know if it's a review of the host or of the room. Okay. So let's semantize this data set. So when I say semantize, it means that I will transform it as linked data. Okay. So we see that in linked data, data is not organized as column, okay, but it's organized as triples. So a triple is a subject, a predicate, and an object. Okay. It's like a phrase. And it represents a fact, a real fact in the real life. Okay? So here we have two facts. We have room 1, price per night is 90. Okay? And room 1 is located in another resource that is London. So this is still structured data, so it's still a machine readable. And we can represent it as a graph, like on the bottom of the slide. Okay, so linked data also use data type, but they use vocabularies. So vocabularies describes real concepts in the real life. Okay? And we use vocabularies to describe their own data in the linked data. So for example, here we know that room 1 is a home, okay? And we know that London is a city. And in the vocabularies, okay, in blue, we know that a home is always located in the concept of place. And the place can be a city, a country, a region, department, etc. Okay. So thanks to vocabularies, now linked data is machine readable, human readable, but also machine and human understandable. Okay. And if we look at other data sets in the linked data, like DBpedia, for example. So DBpedia is the Wikipedia version in the linked data version of Wikipedia. Okay. And if we look at other linked data sets, we see that there are links that are created between our data set and DBpedia. And that's because when two linked data sets use the same vocabulary or describe the same resource, we have links that are created between these data sets. Okay. So it's easier to combine and to query. So that's why we talk about linked data. So if we look at all linked data sets that are available online, we get the linked Open Data Cloud here. So each node is a data set, okay? And each color represents a different topic. Okay? And we have links between data sets. So it's a large amount of data available. For example, here the little node in the center represents DBpedia. So it contains all information of Wikipedia in triples, in facts. So the advantages of linked data, to summarize, first, interoperability, because when we use the same vocabularies to describe data, when we describe the same resources, we create links between data sets, so it's interoperable. Okay. The second one is discoverability, because now in linked data, data is human and machine understandable, and search engine are machine, so it makes them easier to find. And reusability, because the data is human understandable without metadata. So just by looking at the data itself, you can understand the meaning of the data. So it's easier to reuse and it's easier to maintain. So there are a lot of advantages by using linked data, but why? So why linked Open Data Cloud is not bigger? Because it should be bigger if everyone used linked data. So I think there are two reasons why it's not bigger. The first one is that you need to know your data perfectly to semantize it, because you need to understand the meaning of the data. So it limits the number of people who can semantize your own data sets. Okay. Second reason is that for the moment, tools to semantize data, structured data, are mainly created by experts and for experts. So sometimes when you get started with linked data, it can be a little difficult to understand how these kind of tools are working. Okay. And it's the same problem for vocabularies. When you want to find vocabularies to describe your data, find the perfect vocabularies, it can be a little bit difficult to understand which vocabulary to choose, etc. So what we want to do in OpenDataSoft is trying to make linked data a little bit more accessible. Okay. So we think that every data producer that have interesting data should be able to semantize its data set without knowing everything about linked data, everything about vocabularies. Okay. Second thing is that we think that easiest part of a data set should be semantized quickly. So when I say easiest parts, it means that some part of your data set may be already semantized in the linked open data cloud. For example, if you have countries in your data set, it should be easy to semantize this information because there are already other data sets that describe country. And finally, we think that to improve linked open data cloud quality, we think that data producers should only focus on how to describe their data and not on how to use a certain tool or even coding skills. So to tackle this problem, we propose a tool, a linked data chatbot. So the linked data chatbot is able to analyze a structured data. So it will look at column name. It will look at data type of each column, okay? And it will look at the content of each column. And it will try to find relevant vocabulary to use on each column to describe semantically, to link the data automatically. And it will suggest to the user vocabulary to describe the data, okay? But with a really simple question to hide the complexity of linked data. So it can be a yes or no question, or just you can ask to the user to select a specific column of its data sets. So this tool is available online. So it's a beta version. And source code is available on GitHub under the MIT license, so it can be modified. So I show you the advantages of linked data, and I hope I convinced you that it's important when you want to publish data on the web. Okay? And I show you that it will be more and more easy to do it, okay, with new tools like this one. And now I wanted to show you a concrete example of what linked data can really do. What type of features we can implement with linked data. And I will take the example of an open data platform. Okay. So the first thing you can do when you have linked data is exporting it as triples. Okay, so it's an obvious feature. Okay. A second feature that is really interesting is the query the linked data. So the query language in linked data is a little particular because it uses triple pattern, and triple patterns are really close to natural language. Okay, so it's really easy to explain to the query engine what you really want to extract from the data. Okay, so here I have an example of query. Okay, and I can ask him to get all Roman emperors, for example, for the set. I want all Roman emperors born in a specific city. Okay, and with reign began after a certain year. And I will retrieve the results in triples. Another feature that shows the discoverability of linked data are semantic filters. So semantic filter is able to filter a data set on a catalog of data set, but not by using keywords or string inside a title or using metadatas, but filter by what really contains the data, okay? And filter using vocabularies. So for example, here we can ask to the platform to show only datasets that contain the concept of place. So you will get all datasets that contain cities, country, department, region, etc. But you can also filter by a specific concept like city or region. And you can do the same thing with properties. So it means a relation between resources. So for example, you will be able to show only datasets that contain the age of a person or the price of an object, for example. And the last feature is really important in linked data. It's called federated query engine. But to explain you what does that mean, I will take the example of someone who wants to enrich its own data sets. Okay? So imagine you have a data set with a list of plants. Okay? You have just the name of plants in your data set, so it's just a list of strings. And what you want is to add a picture of each plant. Okay? So you don't have this information in your data set, but you know that Wikipedia has this information. For all plants, he have information about the species, he have, for example, pictures of plants. Okay. So what you can do when you use linked data is execute a federated query. So a federated query is just a query that will be executed on multiple linked datasets. Okay. So here I can ask for the query engine to take the plants from OpenDataSoft, so from the first dataset that contains only plants. Okay. Take these plants and send them to DBpedia, and then retrieve all the picture of these plants. And it can extract the information and combine both results. Okay. So this is a federated query. And this is possible because linked data improve interoperability between data. So I show concrete examples of what can do linked data, but we can imagine a lot more of features. And when a platform uses linked data, it can become smarter and smarter. So we can imagine a platform that is able to suggest automatically new combination of datasets. So for example, if a dataset contains country, it can automatically search for information about country on other datasets of the platform and suggest to the user to add some column inside the dataset. Okay. It can generate relevant data visualization because now the platform understands the meaning of the data. So by looking at the vocabulary, it can suggest new data visualizations that are relevant for humans. Okay. And to improve discoverability of datasets in the platform, it can automatically generate metadatas for the dataset. So for example, it can be a little bit long to fill all metadatas in a dataset. For example, description of each column, keyword of the dataset, a description of the dataset, etc. And this can be generated automatically using the vocabularies of the dataset. So I hope I convinced you that linked data is important when you want to publish data on the web, and thank you for your attention, and maybe I can, if you have some question about linked data or
sorry, I missed the very
the mic,
beginning.
you should. Yeah.
So, yeah, housekeeping that I probably should have done at the beginning. Just because we are streaming, if you have a question, I'm going to give you the mic. It won't amplify your voice, but it will mean that it's recorded for posterity and people can hear it. So I'm going to give you the mic.
Thank you. Could you possibly just explain again your pure description of linked data and how does data become linked?
So how the data become links? Okay, so when you semantize data set, okay, you use vocabularies to describe the data, okay, and vocabularies are available on the web. So by using vocabulary that already exists, then you will use the same vocabularies as other data sets. And by using the same vocabularies than other data sets, you will be linked by the vocabularies. But in linked data, there are other links too. So for example, if you describe the same resources than another data set on the linked Open Data Cloud, you will be linked to. So for example, here we have DBpedia, so Wikipedia, have information about London too. Okay. So you will have a link between our London and the London of Wikipedia. And it can be transitive. So if there is another linked data and you are only linked with DBpedia, if DBpedia is linked with another linked data set, by transitivity, you will be linked to the other data set.
Yeah. So can I just give you an example? Perhaps you can explain that, because I operate in the business-to-business environment where things like the names of big companies changes all the time, or everybody has a slightly different version of HSBC, you know, this HSBC something else, or you know, JP Morgan, Chase,
yeah.
and
yeah.
So you understand the problem.
Okay. So in the linked data,
yeah.
Resources are not identified by a name. Okay. They are identified by a URL. Okay. Right. So even if the name of a company or the name of anything change, it will still use the same URL. Okay. So it will have no incidence on the link between resources.
So in your city example then,
yeah.
Is there a URL for London?
Yeah.
Okay.
I hide a URL because it can be difficult to see it in a graph. Yeah. But this is a URL, okay? Each square is a URL, okay? There is just a value that is not an URL. It's just the number 90, but each square is a URL.
Yeah. So I totally understand that with like HSBC or company name, everything works, but in variable names, most of the time you have misspellings or you have different form and so on. It can be variables created in-house, but they are not on online or something like that, specific for the given company. Then how does it work? Does it work then, or?
So if you have information, but the information in different data sets is not the same, is that what you mean?
Yeah, so basically there is a lot of situation when different people or different places you can gather data from. And then you have misspells or shortcuts for given name or something like that. You know that these are exactly the same variable, that the variable can have missing letters because someone else put it wrong or misspelling, or anything like that.
Okay.
So I'm asking about this.
Yeah. So it's clearly an open problem in linked data. Okay, but there are solutions like, for example, confidence score on some data provider. Maybe you should be more confident about using Wikipedia than my data set. Okay. And with this kind of information of confidence, you can correct other data sets. So this kind of mechanism exists in linked data.
And I had a follow-on question from that, actually. So is it possible, kind of in relation to your question, if you have a completely new concept, a completely new item, is there a mechanism in the platform to kind of push that to DBpedia or Wikidata?
Yeah.
And are there like big repositories online for these kind of semantic concepts?
In linked data, in semantic web linked data, we talk about decentralizing the web. So pushing your data on a central repository is not a good solution.
I think I meant more if you come up with an identifier that isn't currently in DBpedia. So if you have a brand new concept, I don't know, like a new type of fruit that you've engineered in your lab or something that no one has ever seen before, how can you contribute that concept to the
So you need to create this resource, create this URI, okay? And you also need to create its vocabulary because it won't exist, okay? And when you created these vocabularies, you should publish your vocabularies online. And for example, we have, so you should publish your data in the linked open data cloud, okay? But about the vocabulary, you should also publish it on these tools, so linked open vocabularies. And linked open vocabularies is a search engine of vocabularies, okay? So you can push your new vocabularies in it, and other people that may encounter this fruit, this new fruit, will use your vocabulary to describe theirs. Okay.
Cool. More questions? Go.
For linked data to work, data sets have to have a structure first, in terms of maybe not columns and rows, but like something that is not unstructured data but structured data in order to be linked. And my understanding is that the majority of the data available right now is not structured. Therefore, this seems like it will happen potentially in the future, but I was wondering if it's something that could accelerate those unstructured data sets nowadays to become semantic and not just go through the traditional process of first structuring it and then semantic.
Yeah, so the chatbot I showed before use structured data, but I know that there are some projects that want to semantize unstructured data, like, for example, PDF text, PDF files. Okay, and it's possible. It's working. For example, I know that there are a newspaper that use this technique, okay, to retrieve facts from a specific resource, like some people get elected at this date, etc. And they can retrieve this information as triples, as RDF, without going through column-oriented data sets. So it's possible, yeah.
So follow-up question, sorry about that. So even if you deal with unstructured data coming from multiple sources, in your data pipeline, is it possible to connect the tool into something else, or how the data pipeline actually looks like for this? So is it like self that you are just downloading CSV files and you have visualization on the tool, or can we connect this to databases or anything else that can actually provide multiple sources of data?
For you talk about the chatbot. If we can connect this one.
So to work with this in organization, what you have different, as I said, you have different sources coming in, and you have even if we deal with structured data, you need to connect this to database or anything. So my question is, do you download the specific CSV structured data into the tool, or you have the data pipeline that is actually connected this, or how does it work inside?
So for the moment, this tool is implemented to get information, to get data on the OpenDataSoft platform. Okay, so it's a specific format. It's a JSON dataset. Okay, but it can be extended to get other types of datasets. It's not complicated, I think, to do that. And it can do it live. You don't here during the semantization process. I do not download all the data. I can download just one part of the data and create the schema, so the vocabularies and columns. I don't need to download all the data to semantize it.
Any other questions? I will abuse my position as chair. Just having a look on your website, and sort of having some discussions earlier, I saw that some of the applications are in city and urban data. And I was wondering if you could talk to us a little bit more about that, about how your tools are helping sort of public city administrations to link up their data sets essentially and make them more usable.
Okay, so for the moment it's a brand new tool, so we are not
hot off the press
still using it on the platform. Okay. We are trying to use it. It's a beta version, so we send it to some users to try it, but we don't have a lot of we don't have recollected enough data to answer this question. I think.
Do you anticipate that throwing up some new challenges? So one of the things that interests me about the semantization process, I don't know if that's the right vocabulary, no pun intended, is that it's a shared picture of the world, and that different people have different pictures of the world. So have you encountered any of that in your kind of journey so far, sending it to different users where they're using standard vocabularies and they're going, that isn't how I sort of link these concepts, or trying to apply it to their own data sets and really not seeing the links there? Have you encountered that at all?
Yeah, it's the same problem when people are generating visualization, because you can create any facts using visualization like graphs or yes, it's a real problem in linked data, because you describe the meaning of the data, so you can describe what you want on the data, but yes, sometimes some data sets could be mis-semantized. It happened, but it's the same problem. I think we can put confidence score on data sets, on data provider, and maybe correct others data set with that. Can be a solution.
Sorry, just kind of related to that challenge about the different way people would categorise or label concepts. Is this a growing area in terms of the data sources? How big is this getting, and do you have any information about how fast the open data sort of world is growing versus people not wanting to put their data out for everyone to use? Because that's a concept I find difficult. I understand it, but I can see at some point it either going away, everybody will share everything, or it will kind of retrench and people will go, hang on a minute, this is actually quite valuable. Why am I putting this out there for other people to use when I've spent, 5 years making it fabulous?
So I can only talk about linked open data cloud because it's my subject, but linked open data cloud is growing linearly. Okay, it should be growing exponentially. So it's not normal. Okay, but I think the main problem is the difficulty to semantize data, because it's a real problem for some data producers. Okay, and the other problem is that main parts of the linked open data cloud is also generated by researchers, for example, or experts in that domain. So it's not. We should have a lot of others data providers, data producers, and it should. With easy to use tools and new tools in this domain, I think we will make this linked open data cloud bigger.
So I can probably speak a bit more to open data in general, because that's obviously a huge part. That's kind of why we're here as an institute. The focus up until now has been on public sector data quite a bit, because there's the principle of it's public sector data, it's been made with public money, it can help in terms of things like transparency. But here at the Open Data Institute, we're really interested in the fact that open data can really drive innovation and this concept of open innovation. So the idea that not just the public sector, but also private companies stand a lot to gain from putting their data out there, because innovation can happen in ways now that are more part of an innovation ecosystem as opposed to a traditional R&D chain. So if you put your data out there can be lots of benefits, if there's mistakes in it, other people will correct it. It becomes much more of a collaborative effort to maintain. So we've got a couple of projects, actually, kind of shameless plug, where we have done stuff up until now with the public sector and helping people within the public sector understand the business case around opening up their data. So what is the actual purpose and the value coming from it, and what are the costs as well, what are the things you need to consider. And at the moment we've just started a project on private sector business cases, where we'll be thinking about value and costs and risks from a private sector perspective. So watch this space. We're doing lots of work to answer that question. Twitter questions. Awesome.
So Ed Forrest on Twitter asks, what does Benjamin see as the most exciting implementation of this today? He's just come across it and is checking out Open Data Bristol, near where he lives, which is also near where I'm from, which is quite nice. But yeah, I wondered if you had an answer to that. The most exciting implementation of this today, of linked data.
So you talk about implementation of the...
I think of linked data in general, I guess.
Okay. I think the most... I heard... I can talk about a project, for example, I've seen in using for linked open data. It was a project I saw in a conference in Semantic Web, and they talk about fake news, for example, and how to use linked open data to detect fake news and to correct this. So I think linked data could be used for this kind of problem. I think, yeah, it's and it's this kind of projects are working. Yeah.
Cool.
Great, thank you.
So we could all have our fake news browser plugins that flag up when a relationship between two resources isn't quite right. Or, yeah, very exciting. Any other questions? And no more questions from Twitter. It's always very exciting when we get a Twitter question, because then we know we're not just weirdly talking into this microphone for no reason. Okay, well, I think all that leaves me to just thank Benjamin for his really, really interesting talk. So
Thank you.
And again, another shameless plug, OpenDataSoft are actually ODI members. So if you are interested in joining our network of members, then come and chat to us. So yeah, thanks so much for coming.